Hi everyone, welcome to the Scale Up Thursdays event today. And with me today, I have Brian McKerr, who is part of the Global Black Belt team. He's an open source specialist uh, at Microsoft, and today we'll be talking about CitusDB. So CitusDB is an extension of Postgres, and it's especially relevant to startups because it's easy to start as a single server with uh, sharding, and then you can scale it all up the way, scale out all of the way to multiple different nodes without any downtime, and it supports both OLTP and OLAP use cases, and it supports this new paradigm of database processing called HTAP. So Brian will walk us through the different features of CitusDB along with some demos. And with that, over to you, Brian. Can you walk us through? And before I hand it over to Brian, I just want to point it out that um, if you have any questions, you can put them in the chat, and we will be taking questions during the webinar, answering any questions that you have about CitusDB, putting it in production, so on and so forth, as we go on. So please keep your questions coming in the chat. With that, Brian, if we can start off.
Thank you, Vinayak. Thanks everyone for your time and welcome along today. And hopefully there'll be some useful information here about Citus in particular, and some of the capabilities of that platform, and some of the new features that will be coming out shortly with Citus 10. So we'll go through those, and as Vinayak mentioned, we'll talk about HTAP and use cases, all of the things that are becoming popular these days, especially as data sizes continue to grow. All right, I'm just bringing my slides up here. Okay, well, as Vinayak mentioned, I'm a technical specialist in the global black belt team, specializing on open source databases, Postgres, MySQL, and MariaDB in particular. And thanks again for your time. So today I'll walk you through what we're going to cover in the agenda. So we'll talk a little bit about challenges that you may have, that we see in the industry, and then we'll go through Hyperscale and what is Hyperscale Citus. We'll talk about some of the features and the benefits, and we'll look at a couple of real life customer use cases. And that's for me, that's one of the real strengths of Citus, is it's a many splendid beast in terms of the types of use cases, OLTP, HTAP, whatever it might be. And then I'll walk you through a little demo of scaling Citus out, and we'll do some Q&A. So let's get into it. Alrighty, so I suppose one of the things that, as most people in IT are familiar with, especially developers and startups, is that they'll be faced with a number of challenges, and it might be useful if you think of what some of your current pain points are to frame this presentation. What we see is for startups, they obviously want to fail fast, but they also want to scale if needed. So that's a key aspect here of Citus. You can set your application up to use Citus and on a single node cluster in Citus 10. And if your project or your application, is successful and takes off, then there's a trivial amount of work that needs to do to scale that to cope with future demands. So it's a really good place to be. You don't have to re-architect if from a database perspective, if your project is successful and you need more performance and more scalability. So yeah, that's a fantastic capability, and I'm sure it's common for you guys. Obviously, we try and make this offering as developer friendly as possible, and we'll look at some of those features there. And by developer friendly, I think essentially that means, for me, we do the heavy lifting from an operational platform maintenance point of view, so that you don't have to be a database administrator, you don't have to be a security expert, you don't have to worry about setting up high availability or backups and all those sorts of things that can be barriers to successfully implementing applications and systems. You also want performance and the ability to increase that performance as it's needed. That's almost in line with the fail fast and scale if needed point above. Ideally, you don't want your data to be sitting there in a silo, so we'll talk a little bit about the integration capabilities that are there in the platform, and that's obviously key. You want to be able to integrate with upstream, downstream, whatever it is, and we've got that covered. And another thing that I see is that there's an awful lot of databases to choose from, and sometimes it's clear which type of database you would use. NoSQL databases are popular, have been for probably a decade now. Some of them have limitations. Some of the relational databases have limitations, but Postgres in particular is, given its extensible nature, it really can cover a lot of workloads. For example, it can cope with unstructured data, and that gives you a bit of flexibility. And if we look at the HTAP use case, then you can see that your online transaction processing database can be the same one that serves your analytics or reporting needs, and that's largely underpinned by the scale-out nature of Citus. Okay. So what is Postgres Hyperscale Citus? Well, as I touched on before, it's a fully managed service, a platform as a service or database as a service offering with PostgreSQL, and it is the standard PostgreSQL that's underneath. It's not a fork, and you wouldn't be locked in. It is standard Postgres. Your applications talk to standard Postgres, whether that's using the PSQL library or Hikari connection poolers or whatever. It is Postgres. It is, and it creates a cluster that can be scaled out. You can also scale up, but everybody can scale up, so we won't talk about that too much. But you can scale out, and what's key here is that scale out, it's a single database. So I know that there are some other cloud service providers who manually shard data across separate nodes. Now those are separate nodes, and you, the developer or the user, have to manage that scaling out, whether that's rebalancing data, moving shards, adding nodes, getting consistent backups of your platform. So that's a key thing here. It's one database, even though it may be spread over multiple nodes in the cluster. You can add new nodes to the cluster, and it's part of the demonstration today. Hopefully, I'll show you how that works, how you add a node and how you rebalance the data so that it's obviously balanced across the total number of nodes in the cluster. In Citus, there are two types of nodes. There's a coordinator node, which you can see in the picture there is the large icon at the top, and there are any number of worker nodes. Now, there's only one coordinator, and it's like the orchestrator for connections from applications, and commands that you want to run are typically run on the coordinator. Now, I'll talk a bit about the upcoming features of that we have for the platform, but for the current system, there's one coordinator and any number of worker nodes. The coordinator is responsible for tracking the node membership and the metadata and the health of all the underlying worker nodes. It also acts, as I mentioned, as the sort of gateway for your DML and DDL. So when a query comes in through an application or through an administrator, then that goes to the coordinator. The coordinator, based on the metadata, knows which node holds that data and sends the query to that node. And there'll be a little diagram that shows that in a bit more detail in a second. And all clients connect to the coordinator and issue queries on the coordinator. And basically, clients don't know that there's worker nodes underneath. And that's part of the beauty of it. Pardon me. The coordinator is a standard Postgres with the Citus extension. The worker nodes, they store the data typically, and it is partitioned across those and sharded. And in the normal operation, when a query comes to the coordinator will coordinate that, gather the results from the workers that have your data, and then aggregate the results and send them back to the client. And that's transparent to the client. So that's it in a nutshell. It's basically scaled out Postgres, and it is still vanilla Postgres from a client perspective, and you get all the blazing performance capabilities. All right, so from a features and benefits point of view, obviously I've spoken about the fact that Citus is an open source extension to Postgres. Now, Postgres is a very extensible database, and there's many features that you can enable in Postgres, and it still means that that's Postgres. So, and that's exactly how the Citus extension operates. There's nothing to stop you running the Citus extension yourself on-prem or in another cloud or however you choose. However, what I will say is that you can only get a database as a service on Azure. So Microsoft acquired Citus data in late 2019, and the only place you can have the database as a service managed Citus is on Azure. You can roll your own if you want because it's open source. That negates some of the benefits, but it's definitely an option for you. One of the things I spoke about earlier, unstructured data. So Postgres itself supports JSON data, and that's kind of like the darling sort of data file format, if you like, yeah. So that can be stored in an unstructured fashion inside a relational database, which it gives you a bit of flexibility. And as I mentioned on the previous slide, there's an awful lot of databases to choose from. If you've got a database like Postgres that can do both structured and unstructured data, it just means that there's less need for you to go and look for something else if you wanted to store some JSON data or XML or whatever, although I think JSON's probably more popular than XML these days. In terms of the managed service, as I mentioned, we do the heavy lifting. We do backups for the platform. You don't have to set them up or make sure that they're working. We do that. It's consistent across the entire cluster. Now, I know some other service providers will try and suggest that you can manually shard. That's pretty difficult to get a consistent backup across your cluster because you've essentially, in the case of a 4-node manually sharded solution, you have to run the backups on all of them so that you can get point-in-time recovery across the whole cluster. We take care of that for you. We have high availability available in the platform, and that means there's essentially an online standby for every node in the cluster. So that's the coordinator and the workers. And in the event of something happening to the primary, within 60 to 120 seconds, the secondary will kick in. The standby will be promoted to the primary, and operations will continue. And that's something that the platform manages for you. And I know a lot of people spend a lot of time trying to implement solutions that do that from a database point of view. So again, that's something the platform does for you. We also take care of security and patching. So latest patches for either the underlying operating system, which is Linux in this case, and the Postgres database. So we'll roll those out as part of the regular maintenance for any databases that you provision. And again, there's less of your time has to be spent on those daily operational tasks. And one of the other nice features is, and this is coming with Citus 10, is we'll have inbuilt connection pooling. Now that simplifies application connectivity and scaling of connections to your database. So that's managed and integrated into the platform, and that would fail over in the event of a failover as well. Excuse me. So one less thing to worry about. And in terms of cloud scale, you can scale up to thousands of cores. So we've got customers who, in fact, we did a demo for a customer the other week who had a 40-node cluster, each one with 16 cores. So that's an awful lot of cores, and each one of those 16 core nodes had 64 gigs of RAM, so 40 times 64 gigabytes of RAM. You can get up to terabytes, and each node has an independent amount of IOPS, so you can easily scale IOPS up to, across the cluster, 500,000 IOPS. Now, the beauty of this is that all of those resources are available to the entire cluster, which means the single database. So the caching of hot data in RAM is spread across all of that memory that's associated with those nodes, and the cores that will answer queries. You're scaling those as well. It's not like you can only talk through the coordinator node. You can, but then the heavy lifting is done underneath by the worker nodes, and you get the benefit of all those resources being available across your entire database. So in this case, if you had a terabyte of RAM and your database was a terabyte in size, then it would practically all be in RAM. So it's not strictly an in-memory database, but it's the same, essentially the same capability. Now, what also we can do is we can scale in excess of 2 petabytes on that single database. Now, I know that there are some limitations on other cloud platforms where, for example, a single database can be 128 terabytes. Well, a single database here could be 2 or 3 petabytes. That's an incredible amount of scale, and there's no operational overhead for you managing that, right? So as you add more worker nodes, as your solution requires either the storage or the cores or the RAM, that all happens independently and seamlessly underneath. And talking about operational benefits, the Citus Hyperscale offering was designed exactly for that, for low management overhead. So we do the sharding, or you choose the shard key for sure, but then the sharding and the rebalancing of data when you add new nodes, that's all happening at the platform level. Like I said, unlike some other solutions where you need to manage that. And if you added a 5th node to your 4-node cluster, how do you start to copy the data across from the other 4 nodes to that new 5th node? Well, I'm sure you can do it. You might lose data. You might have operational downtime. All sorts of things could happen. But with this solution, it's all taken care of. From a platform integration perspective, I mentioned that integration is a key part of this. The Hyperscale Citus offering integrates with the majority of the Azure data and application ecosystem. Things like Azure Data Factory, which is an integration platform as a service that understands that Citus is an option there. So it's in the drop-down lists of sources and targets. You can use that to do ETL, ELT, all of those types of functions. You can talk to Databricks for further analytics. You can also provision Kubernetes clusters, AKS, and they understand that Citus is an option there. So it's fully integrated into most of the usual suspects in terms of the Azure data ecosystem. So you're not, again, it's the silo thing. You don't just have a silo of data. You have a living, breathing database that can scale and can also integrate pretty easily with the rest of the Azure data and application ecosystem. I touched on developer friendly earlier, easy to deploy, compatible with your favorite languages and tools and editors and so on, your favorite ORMs, all of that stuff, whether it's Node.js, .NET, you can plug all of that into it, given that it is just Postgres. You can use pgadmin, you can use dbeaver to do your in-database administration in terms of creating objects, etc. And we've got a whole suite of automation capabilities, such as deployment templates and Azure CLI to automate and script, the key sort of operational tasks. For example, adding worker nodes or setting up connection pooling. All of that stuff can be scripted. Okay, how does the data get distributed? Well, this diagram here shows you on the right. So in this cluster, there's 4 worker nodes. Each one has a part of the data for this customer table that we can see here. So those are the logical shards. So the application sees what's at the bottom of the diagram there. It sees a customer table. The worker nodes have the data spread across them. And when a query comes in, the coordinator knows how to get that data from the worker nodes. So data is distributed at the table level. It can be partitioned and subdivided into shards. So it can also be partitioned, which helps with performance, especially with multi-core CPUs. The shards are distributed across worker nodes in the cluster. The coordinator node understands where the shards are, and that's how it can do distributed query planning, and it knows how to optimally get all that data and return results to the client. And as it says here, each write on the coordinator maps to a shard, and the coordinator is responsible for forwarding the write to the worker node. That all happens using Postgres's two-phase commit, so it's ACID compliant. Transactional writes across shards and workers are managed by the coordinator, and shards can be live rebalanced among workers with no downtime. So how do the queries work? So you see over on the diagram on the right, if you, in this example, somebody's doing a select star from the customer table where the customer is in values 1, 2, and 3, the coordinator will send 3 separate queries off to the worker nodes that it knows has that data for those customers. So to the worker node 1, it will send the query for customer ID equal to 1, and node 2 will be 2, and 3 will be 3. Those results will be returned, and the coordinator will aggregate and send them back to the application. All DML and DDL queries are submitted to the coordinator node for distribution. So any changes to the underlying tables, they aren't made on the worker nodes. Like if you want to change the definition of a table, you do that in the coordinator node. You don't talk directly to worker nodes. For distributed table, the coordinator is responsible for figuring out which worker nodes that the query should be forwarded to. As I mentioned previously, it collects the results, and the coordinator performs the last mile results processing and aggregation. And it's an MPP architecture, so it parallelizes queries across these worker nodes, and you get close to linear performance gains or benefits. So how does it do scale out? So we have a shard rebalancer, and in Citus 10, that's been open sourced as well, that extension, or that part of the Citus extension. So it can rebalance shards live without any downtime. That's a pretty cool feature. So if you decide to rebalance, your application can still run. So if you add a worker node, which is also a non-disruptive operation, by default, that new node won't have any data on it. You have to initiate the rebalance, and when you do, you can still talk to your application. Sorry, your application can still talk to your database, and there'll be a minimal performance impact, as you can imagine. There's quite a bit going on there. And in this diagram here, we've got the unaffected shards are in white. The shard being moved is the sort of dashed line, and the shard to be moved is the light blue. So the light blue is going to the dotted line in this, and the darker blue has already been moved. So that goes on in the background, and again, that's all ACID compliant, transactionally consistent. And what that'll do is that'll spread your data more evenly across the worker nodes, and then you'll get better performance, because it's entirely possible that you could have a lot of your data on one worker node, just due to the nature of the sharding and the shard column. So that's possible, and there's a couple of options for smoothing that out. You can also do tenant isolation, which allows you to allocate specific tenants to specific hosts. So for example, if you had a 4-node cluster, but you knew one region or customer or whatever it might be had more performance needs, you can actually pin them on one of the worker nodes, and then you'll get a bit of sort of isolated resources there, so that tenant will be served quicker, but it also won't noisy neighbor the other less used tenants. Okay. So on Azure, we've actually got 4 Postgres offerings on our database as a service. I'll just walk you through them briefly. Obviously, today is about Hyperscale, just to give you some understanding of where it fits in the picture. Starting on the right, we have single server, which is a fully managed Postgres service. Now, you can scale it up to 64 cores, but once you hit that, then you need to shard somehow, right? So if you've got a workload that needs more than 64 cores, it's CPU intensive, you need to consider how you rewrite or re-architect for that. That's got things like built-in HA and security and whatever. It's a cost-optimized SKU, so it's not as performant as your flexible server, which is the top of the diagram there. That has better performance, and that's down to a couple of things. Essentially, the single server is running on a secure container on a Windows platform, which Postgres and Windows, yeah, you can run it, but is it the most optimal platform for it? No. Linux is a far better home for Postgres, and flexible server is a Linux VM, like a dedicated Linux VM, whereas on single server, it's multi-tenant, secure containers, but the service, as a result, doesn't perform quite as well. We also have zone redundant high availability as an option in flexible server. Now, what that does is that allows you to replicate data across availability zones. So in Australia East, for example, if you set up a flexible server, you can set up your primary in one availability zone in Australia East and your standby or secondary in another. And we do synchronous replication between the primary and the secondary. The platform takes care of that. What does synchronous replication mean? It means zero data loss. So any committed transaction on the primary and availability zone 1 will be synchronously committed to the storage on zone 2. And in the event of an issue with availability zone 1, we will fail over the service for you. Now, that can take 60 to 120 seconds. However, when your database pops up again, when the standby gets promoted to primary and your applications try, we do the IP address to name mapping. So you just connect to the name of the service and it will start accepting connections within 60 to 120 seconds and you're off and running. So that's a really cool feature of flexible server. Custom maintenance window, which allows you to narrow down exactly when those maintenance patches and operating system patches, etc., are going to happen. It just gives you a bit more flexibility. And there's a couple of other features, but flexible server is not GA yet. It should GA probably in the next 4 to 6 weeks. But yeah, just to step you through the options here. Then we've got Hyperscale Citus, which is what we're talking about today. That's distributed, scales out horizontally, but does also scale up. So you can, if you have a 2-node cluster with 4 CPUs, you can scale them up to 8 CPUs each. All worker nodes have to be the same configuration, so that's possible. Once you hit the limit of your scale up, you can then scale out, or you can scale out instead of scaling up. So you've got flexibility there. As I mentioned, beyond 2 petabytes of data. And lastly, we have Postgres Hyperscale on Azure Arc. Now, Azure Arc is it allows you to run workloads in hybrid infrastructure and across clouds. And that's a container-based service, but you still get the Azure management overlay on top of it. So you can run Hyperscale on your own tin in containers with the Azure portal feature on top of it. So that's a great hybrid option. We won't talk much more about that today. All right. Okay, I'll take a pause now. That was a lot of talking and a lot of information. So if there's any questions, please feel free to ask them.
So Brian, yeah, so we have a bunch of questions. If you can stop sharing and maybe turn on a video, we can take those questions. So the first one is by Debesh Das. He's asking a single DB with many nodes. Is it equivalent to the Oracle RAC concept?
I would say yes and no. No, because rack is shared storage. So you have, in the rack example, you maybe have, let's say you've got 4 nodes in your cluster. They're all sharing the same underlying storage. So you have a 4-to-1 relationship between compute and storage, whereas on Hyperscale, it's a shared nothing architecture. So each node has its own storage.
Yeah, I think the related question was like, what are shards?
Shards are basically chunks of data, and those are when you shard a table, when you distribute the table, you choose the column that you want to shard on, and there's a parameter that is a shard count. So you can say I want my shard count to be 10. So underneath, Citus will create 10 shards of the table that you're distributing. Now, if you had 10 worker nodes, it would probably put 1 on each. If you had 5 nodes, it would put 2 on each, and so on. And you've got to choose that number carefully, because if you choose 3 and then you've got 4 nodes, there's going to be a bit of an imbalance there. So a shard is basically a logical part of a table based on, oftentimes it's the and you'll see in my demo, I've got an ID column in my table, right? So I've sharded on the ID column. So it will look at ranges and shard the data based on the ranges to try and evenly spread that data.
Cool. Yeah, another related question is by Ramanathan. So he asks, how is the data? How the data is stored across nodes? Is it similar to HDFS?
Sorry, similar to HDFS?
Yes, HDFS, Hadoop distributed file system.
Yeah, well, it's shared nothing. So each node has its copy of the sharded data that the coordinator decided to send it, and yeah, so in that case, I think it is similar to HDFS, right? It's true sort of scale out, shared nothing, add new nodes. With a new node comes new storage. You can then rebalance onto that shared storage. No other node has a copy of that data.
Yeah, you're right. I think the only difference I think from HDFS is HDFS can have again is a file. You're comparing a database to a file system in that sense. And I think the other thing that I can think of which is different in HDFS is like you have this replication factor. So the same kind of shard, especially if a replication factor is 2 or 3, the same shard can be copied across different. That's kind of different from Citus, I would guess.
Yeah. So
yeah,
that's a good on that
question.
point. On that point, Vinayak. So Citus has 3 different types of tables. And I probably should have spoken about that. There are distributed tables, which will be distributed across worker nodes. There are local tables, which are only on the coordinator node. And there are reference tables. Now, reference tables are tables that are copied to all of the worker nodes. So, for example, if you had an orders table and it was distributed because it was massive, but you had a smaller customers table with maybe only, I don't know, 1,000 customers or something like that, maybe the customers table would be a good option to be a reference table, because then it will be copied to every worker node. And when queries are running to do joins between orders and customers, then the data is on the same node that the distributed table is. So joins become more performant.
Cool. Couple more questions. How is the data? How does the data flow between the DBs in Citus? I think by DBs, DBs means probably means shards, and I think you just explained it, right?
Yeah, I think so. Yeah, so they're all independent, and the worker nodes don't really know about each other. They do, but the coordinator is the one that needs to know that, and so the worker node to worker node doesn't happen that often. The coordinator has the metadata that determines where the data is, so the queries are always sent to the node that will have that data. So there's no concept of, when you rebalance, for sure, the coordinator will tell a worker node, send this data from me to this other worker node, right? And vice versa. So there'll be a lot of traffic going on there. That uses standard Postgres. So that's the standard Postgres communication protocol. And all the worker nodes are basically listening on the same port as Postgres 5432, and they can all talk to each other and share data, but that's typically only when rebalancing.
Great. So a couple more questions. Actually, questions are coming in thick and fast. So what are the complex data types that are supported by Citus PostgreSQL?
Complex. So exactly the same as Postgres.
Yeah, because again, it's an extension, right? So whatever
exactly.
Postgres supports, it's
so
supported.
JSON, XML, there's all the usual suspects, the numerics, the varchars, and IP addresses and whatever. So maybe you could post a link to the Postgres documentation for 13, rather than me come up with what they are.
Yeah, I'll post a link to the data types that are supported Postgres, because that's all supported by
upstream
by Citus DB. Lahiru asks, is it like a active cluster, or is it like active passive cluster? I think he means the part where you mentioned about standby.
So that's active passive. The standbys are uncontactable until they get promoted to primary.
Okay. So Ramanathan is asking, we also have high availability and thick replication is also maintained. So I think what he means is like, how is replication done and how it is used in high availability. I think that's how I'm understanding the question. That's how I understand the question.
A good question. So as I mentioned, when you enable high availability, it's a synchronous replication between primary and standby. So when the data is committed on the primary, it actually commits on the secondary first. And when it gets the nod from the secondary, it then tells the application, yeah, I got 2 copies of this data, and the application goes along on its merry way.
A related question by Taizun, is there any data redundancy within Postgres for a sharded table? What happens if one of the node goes down? I think he means the worker node.
Yeah, then we need to wait for the standby to be activated, which is the 60 to 120 seconds. So your application would get errors. And then when the standby was back, your application would start to be able to query data from that. Well, not directly, but any data from that node would be available.
Good. Yeah, we'll take the last couple of questions. If data from mainframe source of RDBMS, that is DB2, needs to be migrated or replicated onto it, is it supported? This is a question by Ramesh Paradalam.
So actually migrating the entire database, or some sort of integration with data coming out of a DB2 source and being ETL or ELT into Citus? Is that the...
I think he's talking of migrating DB2 from DB2 to RDBMS. Is it supported? Like, are there any tools for the as you rightly said, the ETL transformations, because maybe the data types may not match exactly, those kind of things.
Yeah, look, there's an open source tool, I think it's called DB2 to PG, and it can migrate objects, so tables and indexes and database objects. And I think it claims, I can't remember, it's not a very common use case. It claims to be able to do stored procedures. So yeah, look, I think it's DB2 to PG.
Okay. Yeah, I'll just search for it and post a link to that as you continue the next session. So I'll take the last question here so that we can move on with the presentation. Does Postgres support distributed applications where DB1 and DB2 can be both read-write operating states?
Natively, no. However, my next slide is about what's coming in Citus 10, and I've got some good news on that front in the next couple of slides. So stay tuned, and we'll give you an update.
That's a good question to secure in the next section. So yeah, so Brian, I'll switch my video on, and then you can start sharing the slides again. So yeah, then we'll break again before the demo for the next set of questions. Meanwhile, keep your questions coming in. Brian will be answering them. Thanks, Brian.
No worries. All righty. Good questions, guys. Haven't lost you yet. That's good. All righty. So as I mentioned, Citus 10 will GA in the next couple of months, and it has some really exciting new features, and I'll walk you through some of those features and capabilities right now. Okay, so number one, and we'll see a demo of this today, there is a concept of a basic tier. Previously, you had to set up a minimum of a 3-node cluster, which was 1 coordinator and 2 workers. But with Citus 10, the basic tier allows you to set up a single node, and I've got almost inverted commas here, cluster. When is that useful? Yeah, it's a good question. And imagine, I think I talked about fail fast and scale without any extra development effort. Well, this is one of the use cases here. You can actually set up a single node Citus cluster. You can even distribute your tables. As crazy as that sounds, all it does is it shards the tables underneath, ready for a scale out operation should your application requirements grow. So that's a great option. The barrier to adoption of Citus is very, very low now, and it's still just Postgres, right? So you could actually stand up a single node cluster with Citus and not shard, and just run it as Postgres, and know that with the flick of a switch and a little bit of data modeling, you can turn it into a sharded single node hyperscale, and then add nodes and get all the benefits of those extra resources. So fantastic feature coming up in Citus 10 GA. It's in public preview now in East US and will be GA in a bunch of regions in the next couple of months. Okay, also what we have in the new version of Citus is Postgres 12 and 13 support. So Postgres 13 is the latest Postgres. 14 will probably be released next month. We'll have 13 available, patched up to pretty close to the latest option. That gives you all the Postgres 13 features inside Citus. And there's a lot of performance and reliability fixes and enhancements in both 12 and 13. Another really exciting feature is a major version upgrade, and that can be done in the portal. Now, obviously, you have to test. Like if you were running on Postgres 12 and you thought, hey, something really cool in 13 that I want for my Citus cluster, there's actually a button in the portal that says upgrade. Now, and we do the major version upgrade. Obviously, there's downtime. I don't know how much at this stage, but you would have to test that. So you would have to take maybe you take your 1-node development cluster, which is sharded, but on the 1 node running Postgres 12, and you apply that upgrade and do your testing and your regression testing and your performance baselining. And once you're happy with that, you go, all right, well, it's good to go on my 4-node production cluster, for example. So that's a great feature. Shard rebalancing, you can see a screenshot of it there. in the portal, you can see what's going on with the shard rebalancing. And I'm going to try a demo on that today. Wish me luck. Live demos, I think we all know what that's like, but we'll give it a crack. Another really exciting feature in Citus 10 is support for columnar compression. Now, I put a QR code there. If you want to scan that QR code, it'll take you to a video. And one of my colleagues, Jeff Davis from the Citus engineering team, will happily show you a demo of what columnar compression is and how it works in Citus. Now, it's been released in Citus 10, and it will continue to be enhanced and improved as our Hyperscale offering matures and continues to develop. Essentially, what it is columnar compression, typically used in analytics, where obviously trying to compress rows in databases doesn't yield great results, but if you compress data based on column values, you can see many times better compression ratios. And I think in Jeff's video, it might even be 5 or 6 times more. So what that leads to is less storage being used, faster queries, especially if you're not doing select star, of course. But yeah, click on that link if you want some more details on that. Okay, continuing with the new features, read replicas. Now, this is a really cool feature which allows you to set up read replicas of your cluster across regions, for example. So if you had a 4-node cluster in Australia East, you could set up read replicas, and all the nodes in that cluster would be created in another region if you're choosing, so Australia South, and the data would be asynchronously replicated between the primary cluster and the read replica cluster. So if you had a 1 coordinator node and 4 worker nodes, you would have read replica copies of all 5 of those nodes in another region. You can actually talk to them read only, right? So you can't do updates on them. So it's active passive, but the passive side you can read, unlike the standbys for high availability, which you can't talk to at all. So those read replicas are there. Asynchronous updates means if you absolutely smash your primary with database transactions changes or whatever, those updates don't hit the read replicas immediately. There could be a lag, it's totally workload dependent. It's you would have to test it, but what you wouldn't probably want to do, and I've seen people try to do this, is they would point their application API for writes to the main cluster and reads to the read replica cluster. That can end badly, especially if your application, after it does a write, it does a read. So you can see what can happen there. The write goes to the primary cluster, the read hits the read replica cluster, and guess what? The data doesn't exist because it's still being replicated. Okay, so unlike synchronous replication, there is a delay. You can monitor that delay in the Azure portal. So if you want to test your workload to see what the effects are, you can do that. The typical use case for read replicas are disaster recovery. So you've got an out of region, pretty close from a recovery point objective copy of your data in another region. And then when that's the case, what people do is they tend to run analytics and day after reporting and auditing or whatever on that read replica. What that does is it doesn't affect or doesn't consume resources off your primary. So that's, and you can do that with single server and flexible server as well. So it's the exact same functionality, but it replicates your entire cluster and gives you all of that capability. We also have a managed PG bouncer. I spoke about that before. That's essentially connection pooling built into the Hyperscale Citus offerings. So it simplifies application connection handling, and it's pretty easy to configure. There's a bunch of configuration parameters in the portal. You can set them, and away you go. Custom maintenance windows. Spoke about that for Flex. That will be in Hyperscale Citus 10 as well. Another cool feature is previously, if you chose a shard column like your on your distributed tables and you wanted to change your mind, you had to create a new table and copy your data over. That's not ideal. So in Citus 10, you can now change the shard key on the fly, and Postgres and all its goodness will ensure that that happens in a transactionally consistent manner, and will redistribute your data, reshard your data based on that key. Obviously, if the table's massive, that could take a while. Performance might degrade while that's happening. It might be, I know, 5% or something. It just totally depends on the table layout, the workload, how busy your cluster is, etc. And now the last feature of, well, it's not the last one, it's the last one I'm going to talk about, is MX. Now, what is MX in Citus? Well, it's in private preview today, and it's essentially the concept of distributed metadata. What does that mean? That means, if you look at the little diagram there, that every node in the cluster has a copy of the metadata. So instead of just the coordinator node having the metadata, all of the worker nodes have the metadata. So essentially, those worker nodes can then become or function similarly to a coordinator node. What does that allow you to do? Well, you can read and write to all of the nodes in the cluster. So you could put a load balancer in front, or whatever you wanted to do, or you could in your connection string, you could give your one, in this example, your one coordinator and your 3 worker nodes. You could say, here's your database connection string. Connect to any one of these 4, round robin, whatever it might be. Why is that cool? Well, that's cool because then you can start to use the CPUs of the worker nodes all the time, not just when the coordinator asks them to. So you can essentially, you can bypass the coordinator totally, but what you can see from the diagram is you still have to create tables on the coordinator node only. It's the master and needs to send all that metadata to the worker nodes. But you can run select, insert, update, upsert, delete, copy directly to the worker nodes, and then they will talk to each other. Obviously, that was a question from earlier. Yes, in that case, there will be a lot of intra worker node traffic, but it then becomes similar to rack in that in rack you can theoretically write to all nodes in the cluster. Typically, it isn't set up that way, but you theoretically can. And with this, you absolutely can. We were in a proof of concept with a customer over the last couple of months, and we set up this feature, and they had a requirement of 55,000 transactions per second, which we were able to achieve with the application configured to talk to the coordinator node alone. And when we enabled the application to talk to the coordinator, in fact, just the worker nodes, I think it might have been a 20 node cluster with 8 CPUs, so 160 CPUs. It went from 55,000 transactions per second to 250. So that gives you a feeling of how scalable that is when you can do those transactions across all your cluster nodes. And you can see here the hot standby, which is the HA for each worker node. So that's a pretty cool feature. Now, I might pause and see if there's any questions there, because that might get a few people thinking, oh, that's pretty cool. How does it do this? Or how does it do that? So please feel free.
Cool. We do have a couple of questions.
I'll stop presenting.
We do have a couple of questions. In fact, there's just one question. Can I switch to Hyperscale from existing Azure single server Postgres database easily?
Great question. Yes, you can, because again, remember, Hyperscale is Postgres. So Vinayak, there's some migration guidance on the docs page. If you find that, you can go from single server to Hyperscale, and you have a couple of options there. You can use a logical replication from within Postgres itself to seed that Postgres Hyperscale copy of your data, or you can use a third-party tool such as Stream. You could copy your objects, create your schema, and then use something like Stream to CDC or seed that data across to your hyperscale. Now, what I mentioned before, nothing to stop you doing that, but the secret sauce in hyperscale is the sharding, right? So you would, when you copy the tables, they would only live on the coordinator, right? Because they're undistributed at first, right? So when you create a table in Citus, it's not a distributed table. It's a local table essentially, which means it's on the coordinator node only. So I would say it would be a multi-step migration. You would do that. You would get all your tables on your as they were undistributed on your single server on your hyperscale, and then you would need to determine from your application perspective, do a bit of data modeling to determine what columns you would use, so which tables you would distribute, which tables you would make reference tables, which tables you would leave as local tables, and then you would shard or you would distribute those tables based on the shard key or the column that you identify. Once you've done that, you're good to go, right? Your application doesn't really need to know. It can rely on the coordinator knowing how to find that data on the worker nodes. I mean, you could actually go to a one node cluster, undistributed, distribute and whatever, test, verify, validate, say, yep, this is good, and then scale out or scale up, right? You've got a number of options there.
Cool. I think there's a related another question coming on regarding migration. A bigger table has almost 10 TB of data in the case of Citus, and we need to split the data amongst various nodes. In that case, will all the nodes work as single entity, or how do we approach this? So I think you kind of partly answered the question, right? I think you need to. I think the steps, if I understood that right, Brian, is that first you maybe do a PG dump or do a logical replication, and that may not distribute the table. Then you decide which tables to distribute and what key to use, and then you kind of seed the worker nodes, if I were to use the word, and shard the tables, and and then I think maybe if you have a logical application, then you can switch over with very minimal downtime, right? Any comments on the downtime?
Yeah, look, those are all valid options. If you use the logical replication, I think that's the one. I think those two options, like the PG dump, PG restore, I think those two options are in the documentation, Vinayak. And I think if you do the logical replication, yeah, you can do that with a very small downtime, and the third-party tools also can help in that regard. So yeah, to reiterate, when you do the PG restore, for example, or whatever, it will be a standard local table.
Absolutely.
And then the simple command, I'll show you that in the demo. There's one command that you run that you say distribute this table based on this column, and that's all you do. And then Citus takes over and spreads that data based on shard count and number of worker nodes across your cluster.
Yeah, and I think I want to kind of emphasize one point, Brian, you made, is that the distribution key that is used to distribute the table to shard is very important. So you have to choose it, wisely, because the way you choose it, it will determine, how efficient the distribution of queries and collation of the queries is. So that is something that you should, before you actually do the migration, that is something that you should think about a little bit.
Absolutely.
Okay, the last question, I'm just conscious of time. What is different between Postgres Hyperscale and AWS Aurora Postgres? Yeah, I think I was expecting this question. Yeah, so Brian?
Okay, awesome. Yeah, great question. All right, well, when I spoke earlier about limitations of a couple of things. So Aurora Postgres is not open source Postgres. I would start by saying that. So you can only run Aurora Postgres on RDS. So if there's some other feature there that isn't part, essentially those AWS has forked Postgres. We're Community Edition, and our extension is Community Edition. So point number one. Point number two, I believe RDS is limited to 128 terabytes per Aurora instance. So if you want a 2 petabyte database, how are you going to do that? Well, you can't really unless you manually shard. And manual sharding is not for the faint of heart. There are so many pitfalls, so many situations can lead to data loss. You own and have to manage every single aspect if you manually shard. So if you wanted a 2 petabyte database, how many 128 terabyte Aurora Postgreses would you need to use? Let me see. You need 20 or more. How do you scale if you want to add a new node? And you add a new node, so you go to 21. And remember, these are all independent databases. They do not know about each other. How do you tell your application which Aurora instance has your data? All of a sudden, your application needs to be aware of where your data is. I can see nothing but problems there. Okay, so you can do the manual way. That's kind of like reinventing the wheel, and Citus takes care of all of that for you through some of the features I've spoken about, like the shard rebalancer, consistent backups across those nodes. And so, yeah, those are probably the highlights and lowlights of the two products.
Cool. I think that was a good question, and I was kind of expecting it. So I will also post a couple of links to the petabyte scale that we have, like, for doing Windows analytics in the chat.
Oh, I've got that as one of my use cases. Yeah, I've got some use cases. Yeah, you post that link, and I'll run through the customer use cases.
Yeah. So I'll post a link to the video that talks about this and the blog post. Just a time check, Brian. We have about 20 minutes left in the webinar, roughly about 20 minutes. So yeah, just wanted to kind of let you know. We can. I think you have a demo coming up now. So I think now all the we've talked about theory, and now we'll actually show the practicals. Yeah. So over to Brian again. Looking forward to the demo.
Right. Okay. I'm just going to talk quickly about some of the use cases. Right. So let me jump back in here. I'll quickly go through the use cases because, like I said, there's a lot of database choice out there, and one of the strengths of Postgres and Citus is it can cover many different types of workloads. Alrighty. So. All right, so we've got one here with a shipping logistics company migrated 9 terabytes of data from RDS to Postgres Hyperscale. Very good segue. And they were facing issues with the scalability and performance of, specifically analytic rollups. Now that's one of Hyperscale's really strong points is that rollup. Given the scale-out nature of the cluster, there's enough compute there, there's enough I/O, there's no problem. And this was a mixed transactional and analytical workload. Scheduled jobs, roll-up queries, and this enabled this customer to future-proof their database, and because they were looking at 50% annual growth. Really good one. An electric invoice application, which was used was with Hyperscale. They had a Postgres skills capability. 1 petabyte of data expected to grow 50% over the next 2 years. So again, you can start to see, well, this is a single database, right? I don't want to have to split it and manage different chunks of it. It's just a nightmare. High availability, mission critical apps. The data model consisted of 10 to 15 large tables with an identifier for invoice, allowing the joins. Invoice ID is used as a central distribution key. Monthly partitions, you can still use Postgres partitions if you want. And there's a time dimension on them. So again, another great use case for Hyperscale. Try doing that in a single database. BNY Mellon, if you want to click on that QR code, there's a great video about how those guys use Hyperscale. Now they've got a great architecture there. It's a fascinating use case. They use AKS, they spin it up, they slice and dice data, they put it into Hyperscale. And what does it do? It helps the asset managers understand the investment market and forecast based on a predictive model. They've got terabytes of structured, semi-structured, and unstructured data, and it's all unified in Azure. And Citus is used for both transaction and analytical data processing. So you can see some of the things I spoke about there. Fully managed, highly available, and flexible database. They could scale out multiple instances of the data to optimize reads and writes using parallel processing, and they use JSON-B, one of the darling formats. Here's another one, the Helsinki Road Transit Authority. They're using Hyperscale to dramatically improve performance and reduce costs. You can see that there's a bit of, it's a kind of like an IoT type scenario there. So we've got HTAP, we've got OLTP, we've got IoT workloads. There's all sorts of stuff going on in there. This one uses another open extension, PostGIS, which is a geospatial plugin for Postgres. So you can use PostGIS with Hyperscale Citus. We're not you know, just allowing the one extension. So they had problems with scale and performance and ingesting GPS data. There's your IoT stuff, and the database grew, and so did the query processing. So they just popped new nodes into the cluster. C.H. Robinson created a logistics pricing engine. Again, JSON-B key there. This was an OLAP type, combining OLTP and OLAP, which is kind of HTAP, and customer-facing dashboards, all off a single source of truth, one database. So none of this ETL, take it out of this database, massage it, put it in this one, save it over here, run all that stuff on top of the same database. So we've got ad hoc queries, legacy apps, dashboards, etc. So very powerful, flexible. How many hours and minutes of people's day are spent ETL and ELT? Lots. So this can make all that disappear. This is the one that I think Vinayak was referring to. We at Microsoft actually use Hyperscale, and it's distributed. And this is a quote from the owner of that system in Microsoft. This is to do with Windows Update. 2 petabytes of data, query response time in less than 2 seconds. They use this data to determine ship or no ship decisions for Windows. And so they're taking JSON data from all devices all over the planet, and they're querying that. 2 petabytes of data, 6 million plus queries per day, 75% of queries completing in 0.2 of a second. All right. Okay, I'm going to try a live demo. I've done a few before, and I've had mixed results. But so what I'm going to try and illustrate to you today is the simplicity of the scale out. Now, I've got a single node Hyperscale cluster that I've created. I'm going to show you how I'm going to upgrade that to a multi-node, and I'll show you the shard rebalancer in effect. Okay, let me share my screen. Okay. Is the screen visible?
Yes, we can see the screen.
Okay, thank you. So I've got this Hyperscale cluster here. Its name's HSC001. It is on the basic tier, which is the single node cluster. I can upgrade that to the standard tier, but I'm not going to do that just yet. I just wanted to show you that we've got single node. It has 4 cores and 0.5 terabyte of memory. And I created that earlier. And I'm going to stop sharing that, and I'm going to share something else. Okay, I'm going to jump over to PG admin now. Now, I just want to check, can everybody see those fonts okay? I think.
You might have to increase them a little bit, like at least like double it if possible.
Yeah, okay. Let me, where is it? Let me try and see if I can do this. Oops, that one was a bit too large. Okay, I'll go with this. All right, so I created a table called dist table. Interesting to note that that table is not distributed yet. So I could have chosen a better name, but I created this table, dist table, with these columns. Apologies for the dog barking. The joys of working from home. So there's 4 columns in this table. There's an ID, which is a serial. There's a varchar description. There's a timestamp for date, and there's an amount for float. And then what I did was I inserted 19 million rows in that table using this loop. Now I put that ID is a serial, so it will increment. And I'm using random text for the description and a random number for the amount, so that we get some data in there. That was running a loop. I can find out the size of that table. Okay, so it's 1.5 gigabytes. Now, if I wanted to distribute that table, I would simply run this command. So I'm saying select, and these are the Citus functions, create distributed table of my dist table and shard by ID. One of the cool things that you can do is you can actually undistribute a table. So that can, basically the table is local to the coordinator right now. If I distribute it and then realize I don't want to, I can run this command and it brings it back to the coordinator. Okay. So what I'm going to do is I'm actually going to distribute that table. So fingers crossed, here we go. So you see it says copying data from local table. So obviously it's got that 1.5 gigabytes, which isn't a huge amount. It's got what it's doing now, it's actually distributing it within the one cluster node, right? So it's sharding locally. So after this, nothing will have changed other than the data has been sharded, but it still exists on the only node in the cluster. Once I've done this, I'll actually scale the cluster up. Okay. All right, so it gives us a message there. What size is it? Okay, still 1.5 gigabytes. There's my 19 million rows. All right. What I'm going to do now, I'll stop sharing that screen. I'll jump back into the portal. And I will here we go. Okay. So we can see in here, I can look at the shard rebalancer. I don't think this will show us anything, but this is where you can view the status of the sharded data in terms of it might recommend that you need to rebalance. Well, it's probably smart enough to know that there's only one node in the cluster, so it's as balanced as it's going to get. All right, so I'm going to go into the compute and storage, and I'm going to change to standard. So this is me scaling out. So what I'll scale out to is the coordinator node. Well, there's one of those. It's going to have 4 cores and half a terabyte. And it's going to be 2 worker nodes of 4 cores and half a terabyte. Now, here's the option for high availability. I'm not going to click that. If I click save, you notice it says these changes do not require node restart. But you can't go back the way, right? Makes sense. You just have to do it logically using pgdump or restore or whatever. Okay, so if I kick that off, that'll take a couple of minutes. So now is probably a good time to answer any questions you may have while we wait for this cluster to be scaled up.
Yeah, so we can maybe talk a little bit about maybe the data types that are supported, and also I think the feature that was most exciting to me personally. So 2 things. One is like the data types, because I think someone mentioned using JSONB, and it's quite underrated, because People look at like Mongo and other types of database, but Postgres is quite underrated when it comes to data types. And the second thing, maybe also talk a little bit about columnar compression, because that is also a new feature, and I think it is like again very underrated feature, but it can actually especially for analytics databases where the values are repeated a lot, be a very good feature. Yeah.
Absolutely. Let me share a slide with you while I'm waiting. This is a pretty interesting slide. So Postgres absolutely supports JSONB, and I'll show you something interesting that happened when JSONB was made available in Postgres. Okay. Okay, so hopefully you can see this. So in late 2013, which version would that have been? I don't know, maybe Postgres 11. When it was released with JSONB support, this is a DB Engine's relative growth graph that you can see here. And that was the start, around about then, that was the start of Postgres's ascension. Look at it compared to MySQL and Oracle and even Microsoft SQL Server. So native support for JSONB and the usage of Postgres just skyrocketed. So yeah, absolutely full support for that. Unstructured data in a relational database, best of both worlds. And when you combine that with some of the other features that we'll talk about, I think, as I was mentioning, there's a lot of databases to choose from. In fact, there's too many, right? And people sort of want one, but it can't do this, but I could look at this other one, but it can't do that. So I think one of the great things about Postgres is it's a great all-rounder. Like I mentioned, HTAP, OLTP, even OLAP. We'll talk about columnar compression in a second,
yeah, I think even like the new features for data warehousing, whether it's cubes, whether it is materialized views, the various kind of aggregation functions, I think it's truly an all-rounder in that sense.
Absolutely, and one of the great things about it is it's open source, right? So a lot of people worried about lock-in. A lot of people also have open source strategies. A lot of people, and I'm guessing there's a lot of people listening to this who want to use open tools and open file formats and open databases and open APIs, and the list just goes on, right? And I think, the Postgres guys will say that the world's most advanced open source relational database. I tend to agree, and it only gets better.
Yeah, and I think it does make sense even for startups, right? One, because it's open source, right? And regardless of what kind of deployment strategy you have for a product, whether you want to kind of deploy in containers, whether you want to deploy it on-prem, all of it is kind of supported. And if you, in some sense, even if you want to move to, let's say, another cloud, or as I said, on-prem, depending on the customer situation, you always have the option of exporting data and just working as is, right? Which is not the case with, like someone mentioned, like Aurora, AWS Aurora. That's not the case with Aurora or even Oracle, for that matter.
Exactly. Bingo. Now, this is a good TLDR that I put together as part of this other slide pack, but it's open source. It's got constraints, foreign keys, extensions. The extensibility is a key component or aspect of Postgres. It's got things like PostGIS and, of course, Citus, which is our Hyperscale offering. Bucket loads of index types. It's ACID compliant. There's plenty cloud providers have databases as service options. Not a lot of them using the community version, though, like us, I must say. There's decades of robustness there, millions of users. Foreign data wrappers, so the ability to connect your database to text files or other databases like Oracle. There, window functions, common table expressions, transactional DDL. That's cool, right? Who's ever done drop table and then gone, oh, wrong table? Well, with Postgres, roll back. The table isn't dropped until you commit. Unlike Oracle, you do drop table, you recycle bin or backups. Full text search, another sort of great feature that doesn't get a lot of headlines. Unstructured data, we've spoken about that, JSON-B, rich data types, lots of capabilities in there to see what's going on inside the database with pgstat statements, physical and logical replication, PL/PG/SQL, very similar to Oracle's PL/SQL. So if you know PL/SQL and Oracle, you'll be pretty good with PL/PG/SQL pretty quickly. And of course, procedural language support for whatever. So you want to write a piece of Java code that is run inside the database, Python, Perl, JavaScript, R, knock yourself out. All right, I'll maybe jump back to the scale out and see how we're going there. How are we going for time? We got 9 minutes.
Yeah, we've got about 9 minutes here.
Cool. Hopefully this works. Okay, it's finished. Let me share my screen. Okay, deployment is complete. Let's go here. Oh, let's go overview. Overview. Okay. Okay, so we can see over here, the server name hasn't changed. It's still C dot, which is coordinator dot. There's 4 cores on the coordinator and 2 nodes, 2 worker nodes, and 4 cores each on, for worker nodes, we're running Postgres 13, Citus version 10, and here's the little logical map. So we could easily just go in here and add another one, and worker 2 would appear there. Okay, and you'll see the FQDNs here. You can actually allow access to the workers if you want. But let's now flick over back to PG admin and see what we can do. What we can do there. Right. Okay, so you can see my PG admin. Okay. Well, we never lost our connection to the database because PG admin would have complained if we had. So the table is still 1.5 gigabytes. Let's go and have a look at the shard rebalancer inside the portal. I'm jumping around a bit. Apologies for that. Okay, here we go. Shard rebalancer. Let's see what it says. Okay, so it's saying, hey, I think you need to rebalance. If you view the rebalancer execution plan, there's a bunch of different rebalancing strategies. I'll leave that as an exercise for the reader to find out what those do. And there's the script that you can run. So if we select rebalance table shards and the strategy there, so if I copy that, so there's 21 shards for this table. Let's jump back to PG admin and share it. Oh, can you see my PG admin? Yes, you can, sorry. It just took a second. PG admin.
Yeah, we can see it.
Okay, all right, there you go. So, rebalance table shards. Let's run it, fingers crossed. Okay, doesn't have a replica identity or primary key. So I'm going to add a primary key. That's a boo-boo on my part. Of course, it's going to need that. So this will take a second. Oh. Okay. Now, I think I could try and undistribute the table rather than trying to figure out. Let's see what happens here. And then I'll add the primary key, and then I'll distribute it. Of course, you won't see the shard rebalancer. That's the problem with live demos. The concept there. 4 minutes left. Okay, yeah, so we covered JSON-B. Columnar compression was the other thing that I think you wanted to cover. Yeah, the video on the QR code for columnar compression does a hell of a lot of a better job of explaining how it works than I do, but essentially it is that. Okay, here we go. This is finished now, so we should have all of the rows now. If we distribute by, no, sorry, I'm going to add the primary key. That'll take a second. Yeah, so the columnar compression, as you mentioned, Vinyak, OLAP, where ad hoc queries doing complete table scans. So these things might not use indexes, or they're often not written in an optimal way. They just want brute force to get results, and columnar compression partly answers that. Okay, I've added the primary key, so I'm going to distribute the table. I can't quite remember what the command is to add the primary key with a name, so apologies for that. But it'll have the same effect. What will happen now is, as the table's distributed, it will shard, knowing that there's two worker nodes. So it'll split that table sort of evenly between the two. Well, hopefully it might not, based on the distribution of the primary key, but it should do a good job at that. And if I jump back into the portal, okay. All right, still running. Yeah, look, it might not finish in time, but that's in principle how it operates. Any questions before we wrap up?
There's just one question, and that is there the improvement in table partitioning Hyperscale, like automatically create table partition, or do we need to create manually or using trigger? And yeah, the second question is there an auditing feature available? Because in Postgres we need to enable separate plugins to enable those kind of features. So 2 questions there.
Okay, I'll answer the second one first. PG Audit is an extension that is available.
Okay.
And that I mean, I don't know totally what the requirements are, but yeah, yes, you can use PG Audit. If you can have a look at that, that's one of the supported extensions. And in terms of partitioning, you can partition yourself. I suppose what's going on with the shards is it's kind of like partitioning. So you have to understand the effects of partitioning sharded distributed tables. But yes, it can be done.
Cool.
And that will also help with parallelization of queries. So not only does the distributed query planner know about shards, but it then would also know about partitions and can optimize make use of multi-core on worker nodes, essentially.
Cool. We just extended the webinar by 15 minutes. So any other questions we can take, or Brian, we can quickly go back to the demo if it has and check if it has finished. We can just finish and then wrap it up.
Okay. Let me see.
Meanwhile, you can keep your questions coming. We'll be answering your questions like the PG audit or the table partitioning that we just talked about.
All right, what I might do is I'll cancel that and I'll cancel and I'll create a new table, and we can start from scratch with a bit of a smaller data size, just to give you a feel for it, so that I can insert the data quicker. Okay, so we've got single coordinate of 2 worker nodes, so we'll just add another worker node after I've done this, but let me just set a few things up here. Okay, let me share my screen. Okay, I'm going to create the table from scratch. Okay, table created. I've reduced the data to 1 million rows. It will just generate that dummy data. Okay, I don't need to commit, but it should be 1 million rows. Okay, I'm going to add the primary key on ID. Okay, I'm going to distribute the table. So this will take it change it from a local to a distributed table. Am I still connected? Yeah, there's my 1 million rows. Let's go back into the portal. I'll hit a refresh on the portal. Okay, so rebalancing not recommended. Let's go in and add a, oh, it says it's standard. Okay, all right, let's grow it. 2 worker nodes, 4 cores, half terabyte. Continue. Okay, it's in progress. That took a couple of minutes. What I might do then is I might a bit more about columnar. Okay, so here's the blog post. I'll just zoom in so you guys can see that. I can post that link in the meeting chat. Will that work?
Yeah, I'll just post this in the meeting chat. Yeah.
Right, okay, so you see how simple it is to set up columnar. This create table command will do a heap based, which is the standard for Postgres. simple row table, and here's a columnar table. So simple columnar using columnar. So that says store this data in columnar fashion. And then there's an insert and average row size here. And you can see that the access method for the simple columnar table is columnar and the row table is heap. There's the video link with Jeff Davis, and he walks you through this. So what are the benefits of columnar? Obviously compression, which means less storage. IOs are much smaller, so again, more performance. Projection pushdown means queries can skip over columns that they don't need, further reducing IO. Chunk group filtering allows queries to skip over chunk groups of data if metadata indicates that none of the data in the group will match the predicate. It can skip a lot of data quickly without even decompressing it. And they've got a benchmark here that they run on with certain configuration. They create a table. So that's a normal heap table, then it's a columnar table, and then they insert into the heap table some data. Then they insert into the columnar the same data using a generate series in both cases. Vacuum analyze the tables. Okay, the row table loaded in 2,158 seconds, while the columnar loaded in 1271, so 1.7 times faster. The compression ratio, 8 times. So columnar is 1/8 the size of the heap, and you can see compression ratio of 7.18. Okay, and then when they talk about queries, you can see we'll just skip to the results here. They're running similar queries on heap-based, 444 seconds, and on columnar for the same query, 18 seconds, which represent a 25x speed up. There's a couple of limitations in the first release. You can't update or delete, so you have to insert data into your columnar table, which is quite often the case in data warehousing anyway. You can't have indexes yet, but all these things will be released as the product develops further. Okay, so we reckon now over here. Okay, so we'll go to a shard rebalancer. I think it's saying nothing required at this time. Okay, compute and storage. Let's add another worker node. Let's go to 3. Save. Now, important to note that this is a non-disruptive operation, so I should still be able to run queries with gAdmin. So this table's only 100 megabytes, but that's cool. While the node's being added, okay. All right, so maybe what I'll do now is wait for that extra worker node to be deployed. Any other questions while we've got a couple of minutes while we're waiting for the deployment?
No questions as of now.
Okay. And another thing to note, and Jeff will go over this in the video, the columnar compression and Citus are open source, right? So it's shared with the community. Microsoft has a number of developers who are on the Postgres project. They are source code committers. They help guide and collaborate on the open source community version of Postgres, and that's key when we release these new extensions like Columnar, that gets fed back to the community. Okay, we shouldn't be too long. Kabir, I'm just, sorry, Vinayak, I've just posted another link there with the documentation to the Citus utility functions that explains the functions, for example, creating distributed tables, undistributing tables, creating reference tables, how to set shard counts. So there's an awful lot of configuration and utility function there that allows you to optimize for your own workload, for your own cluster size, etc. So
yeah, I'm just posting the Citus utility functions to the group. Yeah, it should just come up on your screens in just a bit. Cool. Brian, is it done? I think
no, it's still in progress. Still in progress. So yeah, I'll let you know as soon as it's done. All right. So still running. No further questions?
no questions as of now.
All right, I might share my screen because I can see the third worker node. It's there, but the deployment hasn't finished. So let me share this. So you can see here, we now have 3 nodes. The deployment still isn't complete, but we've got 3 nodes, 4 cores. There's the third node.
I still can't see your screen, Brian.
Okay.
Just a second.
Can we see it yet?
Yeah, I can see it now. Yeah.
Okay, well, the deployment's just completed, which is great. There's the 3 worker nodes, the 1 coordinator and 3 workers. If we now go to the shard rebalancer, I'm guessing it's going to recommend that the table is rebalanced. Okay, yep, it is. Okay, it's the same command, so the disk table needs to be rebalanced. So let me share pgadmin with you, and okay, here we go. All righty, can you see my screen? Okay, so I'm going to run the rebalance command. Okay, moving shard, moving shard, moving shard. If I go back into the portal and refresh, obviously this is going to be pretty quick. So hopefully I can get back in time for okay, it's running. So yeah, there you go. Rebalancing is underway. It's 0% complete. Hopefully you can see my screen. I'll just refresh that. Okay, so it's complete. So the data has now been rebalanced across all 3 nodes. Let me just find the function that will allow us to see that.
Brian, should we stop here, or we can quickly finish this because we are way over time?
Let me try. Let me try. Okay, so yeah, I'll share my screen with you so we can see. Let me just run this one command here, and I'll share it with you, and that will conclude the demo.
Yeah, we can't see your screen yet, Brian.
And I'll share it now, sorry. Okay. Window. Oops, wrong one. All right, let me share the PG admin. Okay, so if I run select star from PG dist shard placement, hopefully you can see my screen. And what you can see here is all the shard identifiers and which host or node name holds the shard. So we can see 0, 1, 0, 1, 2, coordinator has something. So yeah, the data is now spread across the 3 nodes of the cluster. We've scaled up with no downtime and no need to tell an application about where the data lives.
Nice, nice. Yeah, we can see the different node names, yeah. Yeah, and the shards, yeah. Cool. Thanks, Brian, for this great demo and the webinar. I think it was very interactive. I think we had lots of questions as well. This will be up on YouTube. And for those who missed it and you want to share, this should be on our YouTube channel as well. If you want to see it again or refer to it again. And we will be back next month with another edition of Scale Up Thursdays, and looking forward to seeing you all there. Thanks, Brian. Thanks for your time, and thanks for the great demo and the presentation as well. Thank you so much.
Thank you. Thanks everyone, and hopefully there's some useful content in there for you.
Thanks, everyone. Bye. Bye.